Okay, in the last section of this unit, we're talking about probabilities of compound events. Okay, so you can see a compound event, that just means that there's more than one event. Okay, and this is a very simple example. If I flip a coin 2 times, what's the probability that it lands on heads both times? So I have more than one event. The first event is the first time I flipped the coin. The second event is the second time I flipped the coin. So there are 2 events there. So we have 2 ways that we can look and try and model what could happen. And then from once we see all the possibilities of what can happen, all the possible outcomes, then we can find probability, right? We need the number of outcomes and the number of ones that we want to happen. Then we can find our probability. So the first way you can do this is by making a table. All right, so my table is going to look like this. All right, I'm going to have basically 4 boxes of a table. Up here will be coin 1. Over here will be coin 2. And each coin, when I flip it, there's 2 things that can happen. It can either land on heads or it can land on tails. Coin 2 can land on heads or can land on tails. This should remind you a lot of the boxes that you were making in science earlier this year, right? So the first possibility here is the coin 1 lands on heads and coin 2 lands on heads. This possibility, this box up here, means coin 1 lands on tails, coin 2 lands on heads. Down here, we've got coin 1 on heads and coin 2 on tails. And in this last box, we got coin 1 on tails and coin 2 on tails. That's it. So there are exactly 4 possible outcomes. So if we want the probability that it lands on heads both times, well, that didn't land on heads at all. 1 tails and 1 heads, 1 heads, 1 tails. This is the only one landed on heads both times. So to find our probability that they're both heads, there's one way that that can happen, and there are 4 possible outcomes. So my probability is 1/4. That's it. That's that easy. Now, there's another way that you can model this as well, other than a table. The other way is what we call a tree diagram. So for a tree diagram, I start by making branches, and I make as many branches as there are possibilities for the first event. So the first event is flipping a coin, right? So there's 2 possible outcomes. So I make 2 branches. One for if the coin comes up heads, and one for if the coin comes up tails. Now, depending on what happened, I have a second event. I flip the coin again. So no matter what happened the first time, I have 2 possibilities the second time. So if I got heads the first time, I have 2 possibilities for the second coin. I could get heads again, or I could get tails. If I got tails the first time, I still have 2 possibilities for the second time I flipped the coin. I could get heads or I could get tails. And now this gives me all of my possible outcomes. What I can do, if I just count how many items there are in the last branch, that tells me the number of outcomes that are possible. So again, 4. This should be the same as this. If I want to see what those outcomes are, I have to follow the branches, and I can actually list them out similar to the way I did in the table. This H up here means I got H the first time and H the second time. So in other words, it's telling me I've got heads both times. This one's telling me I got heads first time, tails second time. So that would be that outcome. This is tails first time, heads second time. And the bottom one is tails and tails. So you can see I got the exact 4 same outcomes as I did in my table. Okay, Some people prefer a table, some people prefer the tree diagram. All right, and it really doesn't make a bit of difference. You get the same information off of both. And again, I can see that one of them had both heads, and there were four possibilities. So again, my probability is 1/4. So they both work the exact same. Now, there is one limitation to the table. I only have two sides on a table, so I can only use a table if there are only two events. If you look at this problem, sub's gone wild. You have many choices when you're making your sub. You have a choice of three types of bread: white, wheat, or rye. You have four choices for the meat you want in the sub. It can be ham, turkey, salami, or bologna. And then you can choose mustard, mayonnaise, or light mayonnaise to put on the sub. So that's three condiments you could put on. So I actually have three different things I am choosing for here. My first event is what kind of bread am I going to get? My second event is what kind of meat am I going to get? My third event is what kind of condiment am I going to put on there? So I actually have three different things. So I can't use a table here because there's only two sides to a table. So I need to use a tree diagram. All right. And what I'm going to do for my tree diagram, I start with the first event, which is bread. And I have three choices here: white, wheat, or rye. So I'm going to make three branches: one branch for white, one branch for wheat, and one branch for rye. Now, the second event is the meat that I'm going to choose. And this time I've got one, two, three, four choices. So off of each of these, there will be four branches. They are for ham, turkey, salami, or bologna. And it doesn't matter what I choose for my bread, I have the same choices for the meat no matter what. So those are all going to be ham, turkey, salami, bologna, ham, turkey, salami, bologna, ham, turkey, salami, bologna. Now I have three choices for my condiment. So off of every single one of these, I have three more branches. So you can see this can get very crowded. And you want to be careful when you're making tree diagrams that you give yourself enough room. I really didn't give myself a whole lot of room here. And every one of these, they could get mustard, mayonnaise, or light mayonnaise. So mustard, mayonnaise, light mayonnaise. Mustard, mayonnaise, light mayonnaise. I'm going to do the same thing all the way through for all of these. There's a mustard, and then a mayonnaise, and then a light mayonnaise. I draw these ones out further. So I didn't leave myself enough space there. For off that ham, mustard, mayonnaise, and light mayonnaise. Mustard, and it's the same over and over. That's why you can see I use abbreviations here. I don't want to write out mustard, mayonnaise, light mayonnaise every single time. That would take forever. And just two left. And the reason I did this is because I wanted to find the probability of someone making a sub with ham on it. So I have to use this table to find first how many total outcomes there are. So I To figure out the number of outcomes, I just count the end here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. There are 36 possible outcomes. So the bottom of my probability will be 36. Now I've got to find how many subs have ham on them. Well, I see up here, here is ham. So there's 3 subs there that have ham on them, right? Down here, there's another ham, 3 more subs. And over here, there's a ham with 3 more subs. So I have 3, 6, 9 different subs that have ham on them. So my probability would be 9 out of 36. That's how you use the tree diagram. It can get long when you have lots of choices, but it'll show you not only how many different outcomes there are, but you can see what those outcomes are. And those are the 2 things you need to find probability.